Hey everyone, welcome to episode 17 of our Neet Chemistry series for 2025 and 2026. I'm Chongtham David, your mentor, and with just 14 days left for Neet, it's time to solidify the bonds both in chemistry and in your preparation. Today's session is all about chemical bonding, the heart of molecular structure. We'll solve 45 must practice questions covering VSEPR theory, hybridization, molecular orbital theory, and more. The concepts that bring together atoms and power your neat performance. Here's something to think about. Strong bonds build stable molecules, and strong discipline builds unstoppable success. Let's learn how to connect atoms and, in the process, connect the dots of your dream. Let's make it count. Your breakthrough is just steps away. Let us see some of the questions that I have prepared for you by starting the sharing the screen. Question number one. The electronic configuration of metal M is given as L1s2, 2s2, 2p6, 3s1. The formula of its oxide will be which are the following options: MO, M2O, SO3, all of this. So from the configuration, we can see that the electronic configuration reveals its monovalent, that is, it is a sodium. Hence, its oxide would be, oxygen has valency 2, M2O. This is the answer for question number 1. Question number 2. Which of the following does not contain coordinate bond? The first, BH4 minus, ammonium carbonate and hydronium ion. So looking at the structure for carbonate, CO3 2 minus, its structure would be as such. There would be 6 lone pair of electron for this 2 oxygen atom. The pair would be 3 and 2 minus. So which of the following does not contain coordinate bond? So C would be the answer for question number 2. R does contain coordinate bond. Question number 3. Which of the following statement is incorrect? The formation of ionic compounds depend upon the ease of formation of the positive and negative ions from the respective neutral atoms. It depends upon the arrangement of the positive and negative ions in the solid, and it involves addition of electrons, while that of negative ion involves removal of electrons, and none of this. So formation of positive ions involves removal of electrons from neutral atom, and that of the negative ions involve addition of electrons to the neutral atom. So option 3, formation of positive ion involves addition of electrons, while that of negative ion involves removal of electrons, is the incorrect answer for question number, is the incorrect statement. That is, the correct answer for question number 3 would be option C. I hope it is clear. Hybridization of the underlying atom changes in which of the following? So what is the formula of hybridization? Half valence monovalent minus cation charge on the anion. So given finding for the correct hybridization which changes from the given one compound to another. So for this, let us first check aluminum hydride. The hybridization of this aluminum in the first option, AlH3, would be hybridization equals valence monovalent minus charge on the cation plus charge on the anion. This would be 3. And this is sp2. However, for aluminum hydride, the hybridization of this aluminum would be half 3 plus 4 minus 0 plus 1. The answer would be 4. This is sp3. So you know that the hybridization changes from sp2 to sp3. A is the answer. You can verify for the remaining species also. For this water, we come to know that it is sp3 and hydronium same sp3 because this one cation would neutralize with this hydrogen, and same thing this cation also neutralize with this hydrogen, and in all the cases this is not the correct answer. So A would be the answer for question number A, 4. Let us see question number 5. The decreasing values of bond angles from ammonia to stibin down the group 15 of the periodic table is due to the bond angle decreases on moving down the group. It is mainly due to the decrease in the bond pair repulsion. You know, for ammonia, it has a bond angle of 107 degree. Since there is a lone pair around the electron, even though it has sp3 hybridization on the central nitrogen atom, its structure would be irregular. Because from VSEPR theory, we come to realize that if there's lone pair of electron, the structure is irregular geometry. So from the expected tetrahedral, it would be pyramidal in nature. Phosphine keeps on decreasing as you go down the group because you have experience of more repulsion due to the increased atomic size on the central atom. Arsine with a bond angle of 91.8, stibin with a bond angle of 91.3, bismuthine, the last element, would be 90 degree. So we can conclude from this point that this can also be explained by the fact that as the size of the central atom increases, sp3 hybrid orbital becomes more distinct with increasing size of the central atom. That is, from pure p orbitals, they are utilized in the metal hydrogen bonding. So B, decreasing in the electronegativity, would be the appropriate answer for question number 5. Okay, let's see the next question. Question number 6. In phosphate, the formal charge on oxygen atom and the phosphorus oxygen bond order are respectively. So let us see the formal charge on this oxygen. O, P, O, O, then you have 3 minus. So resonating structures, let us draw first in order to find the formal charge later on. Still in the trivalent anionic state. So when this double bond keeps on changing, varying, as double bond oxygen. All right. And the final structure would be 3 minus. So how to calculate this bond order? The bond order may be calculated as the number of bonds divided by number of resonating structures possible. So how many bonds we have? We already have pentavalence of 5 bonds and the number of resonating structures is 4. So 1.25 would be the answer. Corresponding to question number 6, the answer would be option C, 1.25 and 0.75. Let's read question number 7. Potassium fluoride combines with hydrogen fluoride to form potassium potassium fluoride. The compound contains the species. Okay, since this fluorine forms hydrogen bond, we can see that both this HF2 minus exists. Therefore, this compound potassium hydrogen fluoride gives potassium ion and anions. So C would be the answer for question number 7. Let's read question number 8. An ether is more volatile than an alcohol having the same molecular formula. This is due to in alcoholic intermolecular hydrogen bonding is possible, whereas in the case of ether it is not possible. So D, intermolecular hydrogen bonding in alcohols. So option D would be the correct answer for question number 8. Question number 9. In which of the following ionization processes the bond order has increased and the magnetic behavior has changed? So in nitrogen, the bond order is 3 and it is paramagnetic, whereas in N2 minus, the bond order would be 2.5 and it is paramagnetic. In carbon, diatomic homonuclear, bond order is equal to 2 and diatomic. Then in the C2 plus, bond order is 1.5 and still paramagnetic. In nitrogen nitric oxide, bond order is 2.5 paramagnetic, and in NO plus, bond order is 3, it would be dimagnetic, and an oxygen molecule bond order would be 2 and paramagnetic, and the bond order in O2 plus would be 2.5 and it is paramagnetic. So nitric oxide, the bond order has 2.5 and paramagnetic, whereas in NO plus, bond order is 3 and dimagnetic. So question is asking, in the ionization process, the bond order has increased and magnetic behavior has changed. So this would be the answer, because as we have already discussed, the nitric oxide bond order is 2.5 paramagnetic, and in the case of NO plus, bond order is 3, so there is an increment of zero point 0.5. So question is saying which is increasing, zero point 0.5 is increasing, magnetic behavior change from paramagnetic to dimagnetic. So answers option number C for question 9. Okay, let's read question number 10. The maximum number of 90-degree angles between bone pair of electrons is observed in. So if we carefully study again the hybridization, the DsP2 hybridization, it has a geometry of DsP2 square planar complex as such. And the number of 90-degree bond angle between them will be 4. And in the case of sp3d, the hybridization of the central atom would be sp3d, and it is trigonal bipyramidal. Number of 90-degree and the bond angle between them would be 6. 90-degree, number of 90-degree is 6. This is sp3d. And for octahedral complex sp3d2, let us count the total number of 90-degree bond angle. This is sp3d2. So there would be 12 number of 90-degree angle between the bonds. So the answer for question number 10 would be sp3d2 hybridization. Moving on to the next question, number 11. Two ice cubes are pressed over each other until they unite to form one block. Which one of the following forces dominate for holding them together? I hope some of you would find this familiar. It is due to hydrogen bonding. C is the answer for question number 11. Let's read question number 12. In genin difluoride, genin tetrafluoride, and genin hexafluoride, the number of lone pairs on genin are respectively. So in genin difluoride, the total number of valence electrons of genin would be 8, and 2 electrons shared with 2 fluorine atoms, 6 electrons left, hence 3 lone pairs would be present. Whereas in the case of genin tetrafluoride, 4 shared with 4 fluorine atoms and 4 left, hence the 2 lone pairs. In genin hexafluoride, 6 electrons are shared with 6 fluorine atoms. So 2 left, hence 1 lone pair. So for question number 12, 3, 2, 1 would be the answer for number of lone pairs on genin. 3, 2, 1. So answer would be option D. Moving on to the next question, number 13. The hybridization of atomic orbitals of nitrogen in NO2 plus, NO2 minus, and NH4 plus are in this first ion or particles, this NO plus, NO2 plus. The number, okay, the hybridization will be 5, 0 plus 0 minus 1. So answer is 2. So SP hybridization. Whereas in the case of Na2 minus, it would be half 5 plus 0 plus 1 and minus 0. So for this, the answer is 3, which is SP2. In the case of ammonium ion, NH4, half 5 plus 4 plus 0 minus 1. So it would be 4 SP3. So for question number 13, SP, SP2, SP3. This is the answer for question number 13. I hope it is clear. Let us rate this match in the column with column 1 and column 2. In column 1, you have the molecule, number of lone pairs on column number 2, and shape in the column number 3. So let us pair them up. This ammonia would be having 3 bond pair, trigonal pyramidal. Sulfur dioxide would have 2 lone pair and 2 bond pair, and it is band shape. And silicon tetrafluoride, it would have 11 pair and 4 bond pair, so same, it has seesaw shape. And chlorine trifluoride, it has 2 lone pair, 2 bond pair, and hence the shape would be T shape. So after matching, we would be getting sulfur dioxide 2. So this would be the answer. Question number 15. Which of the following statements are not correct for combination of atomic orbitals? Atomic orbitals having same or nearly having the same energy will not combine if they do not have the same symmetry axis. And in this 2pz orbital of one of atom, it cannot combine with 2px or 2py orbitals of the other atom because of their difference in the symmetries. So we can say 3 is the only correct answer. Still they cannot combine. Moving on to question number 16. Which of the following is the correct increasing order of lone pair of electrons on the central atom? So for this IF7, it has number of lone pair electrons on the central atom 0, IF5 1, CLF3 2, and xenon difluoride would be 3. So the correct increasing order would be IF7, IF5, CLF3, then xenon difluoride. So in this pattern, you can arrange IF7, IF5, CLF3, and xenon difluoride. So A would be the answer for question number 16. So this number of lone pairs of electrons in central atom in the various atoms you need to first find out, then increasing order of this number of repulsion which can be arranged later on. Let's read question number 17. The dipole moment of chlorobenzene is 1.5. What would be the dipole moment of 1, 2, 3, 5 tetrachlorobenzene? So let us first figure out from vectors rule. From here, you know that the angle is 120 degree. So these are 5 chlorine and 5 chlorine, they are vertically cancelled, opposite in direction, and dipoles of 2 chlorine we are going to find out. So what will be the resultant magnetic moment? Mu square 1 plus mu square 2 plus twice mu1 mu2 cosine of the angle between them. So simply substitute 1.5 square 2 into 1.5 into 1.5 cos 180 degree, 120 degree. So the negative moment would be 1.5 approximate. 1.5 dBi. Let us proceed to the next question, number 18. In compounds of type ECl3, the angles of Cl, E, and Cl for different E are in the order. So this BCl3, its hybridization is sp2 hybridization and trigonal geometry bond angle with 120. In PCl3, you have pyramidal geometry, and in arsenic trichloride, you have pyramidal geometry. Even in bismuthine, you have trigonal pyramidal geometry. So the bond angles below 109 degree 28 inch and decreases from this phosphorus chloride to bismuth chloride. So the answer for question number 18 would be boron, phosphorus, arsenic, and bismuth. This is the answer for question number 18. Question number 19. Which of the following substance has the greatest ionic character? This is also a frequently asked question based on Fajan's rule. Covalent character is inversely proportional to size of the cation. So among the given species, order of size of cations follows N3 plus, O2 plus, Pb plus, and Ba2 plus. Whereas the order of the size of the atoms and ions would be O2 minus is greater than less than chloride. So the increasing the order of this covalent character would be NCl3. It has the highest. Let us first arrange the sequence NCl3 followed by Cl2O followed by PbCl2 then BaCl. So what would be the answer for this? Which of the following has the highest ionic character? So it would be option NCl3b. According to this, you have barium chloride, so it must have the highest or most ionic in character. Okay, let's read question number 20. If an organic compound contains 92.3% and 7.7% hydrogen, then number of sp2, sp3, and sp hybridized or bicarbon orbitals in the possible structures of compound relative respectively are. And the given molecular mass is 52 gram per mole. So let us see. We'll consider in this way. Let amount be X, or let us say 100 gram because it is given in percentage. Let the amount of the compound. Let the amount of the compound be 100 grams. Then number of moles of carbon would be 92.3 divided by its atomic mass 12. So it would be 7.96. That is 7.77 gram. Anyway, for this number of moles of hydrogen, that's right, mole of hydrogen would be 7.7. Now, what is the empirical formula of the compound? It is CH, let us say. And the empirical formula mass would be empirical formula mass of the hydrogen would be 12 plus 1. It corresponds to 13. So the molecular mass of the solid would be 1352 divided by. So from this we can conclude that this m is 52 divided by 13. So it will be 4. So molecular formula can be predicted as C4H4. Now from this we can draw how many possible structures are there. So there would be 084 084. So this is the answer for question number 20. 21. Which of the following are isoelectronic and isostructural? So this nitrate and carbonate have same number of electrons equal to 32 and central atom in each being sp2 hybridized. They are isostructural too. So we can say nitrate and carbonate. Option 1 is the answer for question number 22 and 21. Question number 22. Consider the chemical species nitrate, nitronium, and nitrite and carry out the correct statements given below. So the hybrid state of nitrogen in nitrate and nitrite so is the same, and it is while it is sp2, while in the case of NO2 plus, it is sp. So answer D would be the answer for the question number 22. So the hybrid state of nitrogen nitrate and nitrite are the same. Let us see question number 23. Bond angle bond order normally gives ideas of stability of a molecular species. All the molecules, namely hydrogen, lithium, and boron, have the same bond order. They are yet not equally stable. So the stability order is. Now remember the molecular orbital configuration. For hydrogen, you have sigma 1s2, so no electrons, no antibonding. And in the case of lithium diatomic homonuclear species, its configuration is sigma 1s2, sigma star 1s2, sigma 2s2. So there are two antibonding electrons. In the case of boron, it has sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2. So, and followed by pi to px1, pi to py1, and pi to pz1. So, four antibonding electrons may be feasible here, and the bond order of all the species are same, but stability will be different. So, this is due to the primary difference in the presence of number of antibonding. 22, let us come to 23. 23 answer would be D. 23, D. Fine. Let's read question number 24. In this above nuclear reaction, this is called, okay, the formation of a heavy nucleus from those of the lighter elements is known as nuclear fusion. And the mass of the heavier nucleus is always less than that of the sum of this mass of lighter nuclei, which is converted according to Einstein's mass energy relation equals to mc square. So 24 nuclear fusion is the reaction for this particular given question. Question number 25. Hydrogen chloride molecule contains a gaseous HCl molecule has hydrogen and chlorine. They are linked by a covalent bond. Hence, their electronegativity of chlorine is greater than that of dihydrogen. So due to this, the shared pair of electron is more attracted towards the chlorine. So thus chlorine and this N of this molecule, they has higher electron density and become slightly negative, and the hydrogen and slightly positive. So the covalent bond in this HCl and it will have a polar character as such. Chloride, del minus, del plus. Moving on to question number 26. Among the following species, identify the structural isostructural pairs. So hybridization in NF3 and hydronium are sp3 and they have pyramidal structure. So this hybridization in nitrate and BF3 that will be sp2 and they have trigonal planar structure. So 26 would be NF3, H3O plus, and nitrate and BF3. In the anionic form of carboxylate, the two carbon-oxygen double bonds are found to be of equal length. What is the reason for it? Okay, for better understanding, we can write it here. A glimpse of the ion. 1, 2, 3, 4, 5, 6. Then you have this carbon and hydrogen. Now, when resonance takes place, This would come here. So hybrid resonating structure would be carbon, oxygen, then oxygen followed by carbon, carbon double bond. Okay, so 27 C would be the answer. The anion having COO minus has two resonating structures. Let us read question number 28. Which of the following are not essential conditions for hybridization? So the promotion of the electron is not an essential condition prior to hybridization. It is not necessary that only half-filled orbitals participate in hybridization. In some cases, even filled orbitals of valence cell take part in hybridization. So D would be the answer. Question number 28. Very good. Let us read question number 29. The molecule XY2 contains two sigma and two pi bonds and one lone pair of electrons in the valence of X. What is the arrangement of lone pair and bond pair? So since this XY2 forms two sigma and two pi bonds and has one lone pair of electrons, it must have the structure as such. So since this XY2 forms two sigma and two pi bonds and has one lone pair of electrons, it must have the structure YXY. So hence this Y is divalent. And the hybridization of X is sp2. So XPT XY2 will be having trigonal planar like sulfur dioxide. 29 would be answer B. Moving on to next question number 30. The molecule BF3 and NF3 are both covalent, but BF3 is not polar, whereas NF3 is polar. The reason is the shape of this BF3 is trigonal planar, FBF, and the dipole moment symmetrical, so mu equals to 0, hence it is non-polar, and the shape of BF3 is pyramidal, and hence it is polar in nature. So 30 would be question number 30. The answer would be D. 31. Okay, among lithium chloride, rubidium chloride, barium chloride, and magnesium chloride, the compounds with the greatest and the least ionic character are. So according to Fajan's rule, the smaller or highly charged cation has greatest covalent character, while the large cation with smaller charge has greatest ionic character. So 31 would be B. 32. Which of the following is the wrong statement? So these first two elements, they are not isoelectronic because one contains 32 electrons and the other contains 28 plus 7 plus 8 plus 1. So 28 electrons, 32 and 28. What about the shape? This central atom is sp2 hybridized with one lone pair and it is pale blue gas. So at 249 degrees Celsius, it will form a violet black crystals and it is diamagnetic. So D. Let us read question number 33. For which of the following molecules are significant? Mu equals to not equals to 0. So let us draw the structure of this molecule. 33. OH One is para position, and the others they are the hydroxy group present in the okay, both one is thiol and cyanide. So in both these molecules, which I'm going to draw, first erase all this. In this first molecule and the subsequent molecule. So both the molecules, the bond moments are not cancelling with each other, and hence the molecule they have a resultant dipole moment, and hence the molecule will be polar in nature. So both is 3 and 4. So option D would be the answer for question number 33. Let's read the next question. The bond dissociation energy of BF in BF3 is 646, whereas in CF4 is 515. The correct reason for higher fluorine bond dissociation energy as compared to chlorine fluorine is. This the reason is the delocalized pi bond bonding. I can help you with the diagram. Right. So here you have the structure of BF3, chlorine and fluorine. So the delocalized p pi bonding between filled p orbitals of F and vacant p orbital of B leads to shortening of BF bond length, which results in higher bond dissociation energy of BF bond. One is vacant and another one is filled. This fluorine is filled and this boron is vacant. So significant p pi interaction between fluorine and boron in BF3 where there is no possibility of such attraction in CF4. So the answer would be B is the correct answer for question number 34. I hope it is understood. Let's move on to the next question number 35. The dipole induced dipole interactions are present in which of the following pairs? So this type of attractive force operates between the polar molecules having permanent dipole moment and the molecules lacking permanent dipole. So in case of HCl, which is polar, magnetic dipole moment will be 0, and in case of helium it is non-polar, so it will not be 0. So it gives the dipole induced dipole interaction is the correct answer. So dipole dipole interaction would be best found in HCl and helium. So option B for the question 35. Question number 36. The number and types of bonds in carbide ion are. So the structure of calcium carbide is, can draw the structure here, calcium, and this is a structure of carbide. It has one pi bond and two sigma bond, one pi bond and two sigma bond. So one pi and two sigma would be D, two, one pi and two sigma bond. So D is the answer for question 36. Let's read question 37. Which of the following method is used for measuring bond length? Bond lengths, they are measured by spectroscopic or X-ray diffraction and electron diffraction techniques. So X-ray diffraction, electron diffraction, spectroscopic technique, all of this would be the answer for question 37. 38. Which of the following molecules have the same bond order? So in carbonyl, 3 shared electron pairs present between carbon and oxygen, and so the bond order would be 3. So for nitrogen bond order is 3, hydrogen, chlorine, and bromine would have identical bond order, that is 1. So both A and B, because 1, 2, and 4 they have bond order 1. Same, but in the case of nitrogen and carbonyl, they will have bond order 3. Both A and B correct. So option C would be the answer for question 38. 39. Which of the following are misconceptions with respect to resonance? The molecule exists for certain fraction of time in one canonical form and for other fractions of time in another canonical form. So the statement is correct. The canonical forms have no, this is not correct. There is no such equivalent between the canonical forms. So only A is the answer for question number 39. Moving on to next question number 40. A neutral molecule XF3 has a zero dipole moment. The element X is most likely. So BF3 has a planar and symmetrical structure. Thus, as a result, the resultant of two bond moments being equal and opposite to the third will cancel out, and hence the molecule possesses zero dipole moment because it is symmetrical in nature. So 40 would be boron. X can take chlorine, boron, nitrogen, or carbon. Okay, the species having pyramidal structure or shape would be. So you need to find the hybridization of all this. So let's see. In case of OSF2, the hybridization is 6 plus 2 by 2. Because initially I've already explained you can find hybridization from this formula as well. Cation anion. Simplifying this, since it is not having any cation anion, we're just simplifying. Valence is 6 plus 2 plus 0 plus 0. Divided by 2, it would be 3. So it has, no, 8, right? So 8 would be, 8 by 2 would be 4. Since it is 4, you have one lone pair, sulfur double bond F. So it is trigonal pyramidal, the shapes of sulfur trioxide, BrF3 and SiO32 minus, they will be trigonal planar in structure. Next question number 42. The bond order of 1.5 is shown by. So in oxygen, we already knew the bond order is 2. So if I add one more electron here, the bond order would be 2 by 1. So in case of O2, no, it would be sigma 1s2, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2, pi 2py2, and pi star 2px2, pi star 2py1. So bone order would be, if I count 10 minus 7 by 2, 3 by 2, 1.5. So answer will be option B. That's it. Question number 43. Which of the following properties are not shown by nitric oxide? Nitric oxide is paramagnetic in the gaseous state because of the presence of one unpaired electron in the outermost shell. And the electronic configuration of nitric oxide would be 1 sigma 1s, sigma star 1s2, sigma 2s2, sigma star 2s2, sigma 2pz2, pi 2px2 equals to pi 2py2, pi star 2px1, star x1. Okay, so 43, it would have a diamagnetic character because of the presence of lone pair electrons. 44. Sorry. Okay. It should be diamagnetic because of absence of lone pair of electrons. 44. The charge or radius ratio of a cation determines its polarizing power. Which one of the following sequence represents the increasing order of the polarizing power of the cations? So smaller the size, according to the first answer, higher the charge, more will be the polarizing power. So the order of the size of cation would be potassium, followed by calcium, magnesium, beryllium. So the correct order of polarization power would be potassium, calcium, magnesium, barium, beryllium. Okay, D would be the answer to question number 44. And as usual, you solve this question number 45 and give the answer in the comment section. Thank you for joining up to the end. We shall meet in the next episode.